Hello, everyone. I am Aliaksandr Valialkin, CTO at Victoria Metrics, and I'll talk about how to efficiently manage logs in large-scale Kubernetes clusters. I'm a software engineer, and I like writing fast code in Go. I work mostly on specialized open source databases such as Victoria Metrics. This is time series database, and recently I started working on VictoriaLogs. This is a database for logs. Let's get some bits of Kubernetes, how Kubernetes is built. What is Kubernetes cluster? Kubernetes cluster contains of multiple nodes, this regular hosts with CPU, memory, and network. And all these nodes are controlled by a Kubernetes control plane. Every node contains multiple pods, many pods, and all pods in a single node are controlled by kubelet, part of Kubernetes. And when we zoom in into pod, we can see that every pod can contain multiple containers. Every container runs some Docker image. And every container may have some limits on CPU and memory. These containers may share some persistent volumes. And when we look at logs, logs in Kubernetes are mostly generated by containers. So every container may generate logs, its own set of logs. Let's look at log sources in Kubernetes. The first log source is Kubernetes containers, which are part of Kubernetes system. This is a control plane. These containers include AP server, etcd, kubectl, and so on. And also node containers, which include kubelet, kubeproxy, container runtime, and so on. Another type of Kubernetes log sources is user containers. And user containers generate most of the logs in Kubernetes, because users deploy a lot of containers, and these containers may generate a lot of logs. Let's look at Kubernetes container logs. The typical destination from Kubernetes container logs is std_out and std_r. Also, logs may be generated to custom files, and also logs may be generated and shipped directly to some external database for logs. But as I said, default destination for logs in Kubernetes is std_out and std_r. How does Kubernetes collect these logs? Kubernetes automatically collects std_out, std_r logs from every running container. And these logs are stored in distinct files on the local Kubernetes node where these containers run. Every log file for every container is limited with 10 megabytes by default. All the logs are automatically dropped. For instance, if you have container which generates a lot of logs, more than 10 megabytes, then you can see only the last 10 megabytes of these logs. And logs for stopped containers are eventually dropped by Kubernetes, so they don't occupy space. And such logs in Kubernetes containers can be expected with kubectl logs command. Here is an example how you can run this command. You specify pod name and container name, and you get logs directly from command line. kubectl logs has the following features. It scales to any number of containers because, as I said before, every container puts its own logs into local file system on the local host, so it can scale to arbitrary number of hosts, nodes in Kubernetes. kubectl logs supports a live tailing feature such as tail-f, so you can investigate logs in real time for any container. And kubectl logs is a command line tool which has good integration with other Unix command line tools. So you can pipe output from kubectl logs to some grep, head, tail, and so on. But kubectl logs has issues. The first issue is that it allows you investigating only the last 10 megabytes of logs per container. Also, you cannot investigate logs from stopped containers because such logs are deleted. Also, kubectl logs doesn't provide you the ability to quickly search over large volumes of logs across containers. For instance, you cannot find logs with containing some trace ID across many containers, for example. And also, kubectl logs doesn't provide tools for log analytics. For example, you cannot find top 5 containers which generate the most of logs during last hour. Let's think which are requirements for large-scale logging for solution for Kubernetes. The first requirement is that this solution should forward all the logs from all the containers to a centralized database for logs. Why is this important? Because this allows managing all the logs in a centralized manner. It's much simpler than managing logs located on every Kubernetes node. And this also allows querying all the logs at once. So you can find some logs containing some trace ID across all the containers, for example. And what about requirements for such database? The first requirement is that it should efficiently accept and store huge volumes of logs. And the second requirement that it should provide fast full text search over terabytes of ingested logs. Otherwise, you will wait for eternity when you're searching for something in log. And it would be great also if such solution provides fast analytics over billions of ingested logs. Let's look at some databases which can be used for Kubernetes logs. Let's start with traditional databases such as MySQL or Postgres. Yes, you can store logs in these databases, and they work okay for small volumes of logs when the number of logs doesn't exceed a few tens of millions, for instance. But when you try ingesting more logs to these databases, then you will face some scalability issues because traditional databases are not optimized for storing huge volumes of rows and logs. They need a lot of disk space, disk I/O, memory, and CPU for huge volumes. And also, traditional databases do not contain special functionality for logs ingestion and for logs querying. So you need to figure out how to ingest logs and how to query them. What about analytical databases such as ClickHouse? It scales great for large volumes of logs, and it has very good performance for querying of large volumes of logs. The first issue is that it's not trivial to configure it properly for specific sets of logs. You cannot create general purpose ClickHouse table for any types of logs. For instance, for all logs with any set of fields for logs from any source, you need to specify which fields these logs should contain, and you need to specify for the proper order of these logs and proper partition for these logs in order to get the maximum possible query performance and maximum possible efficiency for storing such logs. And as in the same way as traditional databases, ClickHouse needs custom tools for logs ingestion and query. You need to translate ingested logs into insert statements, and then you need to translate some queries from user interfaces to SQL queries at ClickHouse. Let's look at database document indexing databases such as Elasticsearch, OpenSearch, and so on. They provide fast search over and analytics over large amounts of volumes of logs, but they have issues that they are not non-trivial to stop and operate. And also, Elasticsearch likes memory a lot. So if you ingest a lot of logs into Elasticsearch, you need terabytes of memory for efficiently querying these logs. Let's look at specialized databases. The first specialized database is Grafana Loki. It provides good compression for logs. It stores logs in compression form on disk, but it has issue that it slowly searches over large volumes of logs because it needs to scan all the terabytes of logs when you search for some string in these logs, and this is not good. Also, Loki doesn't support high cardinality log fields such as user ID, trace ID, or IP, which may contain unbounded number of unique values. And Loki is hard to configure and operate properly. And what about VictoriaLogs? It is very simple to set up and operate, contrary to other systems. It has very low disk space usage. Our performance tests show that it needs up to 15 times less disk space than Elasticsearch for the same amounts of logs. And it needs very low memory usage. It needs up to 30 times less memory than Elasticsearch. Put it another way, that you can replace 30 nodes cluster of Elasticsearch with a single node of VictoriaLogs for the same amounts of logs. And it provides fast full search over large volumes of logs in similar way as Elasticsearch from user's perspective. And it works perfectly with high cardinality log fields such as user ID, trace ID, and IP. Let's look closer at VictoriaLogs. This is open source database for logs, which I'm working right now. It is very easy to set up and operate, as I said. It contains a single small executable without any external dependencies, which runs optimally with default configs on any scale, starting from Raspberry Pi to computers with hundreds of CPU cores and terabytes of memory. Its performance and capacity automatically scales to the available resources. It supports popular log shipping protocols such as syslog, Elasticsearch, Loki, Vector, FileBit, OpenTelemetry, and so on. You can read about this on this link. Also, VictoriaLogs provides its own query language, LogsQL, which is very simple but powerful. We'll look at this query language in a few moments. It provides interactive command line interface for querying, which is named VLogsCLI. It provides also web UI for querying if you don't like command line interface. And it provides rich HTTP querying APIs, which can be used for integration with third-party tools. And the last thing, which is very useful, is that VictoriaLogs provides live tailing functionality for query results. Let's look at LogsQL query language. As I said, it's very easy to learn and use. It is optimized for typical log analysis tasks over structured and unstructured logs. So you can ingest and query both structured and unstructured logs in VictoriaLogs. LogsQL supports data extraction and transformation at query time. So you can extract some useful information from unstructured logs and then perform some analytics on extracted information. Let's look at some examples of LogsQL. The simplest example is to select all the logs. You just type star and that's it. That's a query language which a LogsQL query which selects all the logs in the database. And don't worry to perform such query on VictoriaLogs database, which contains billions of logs. VictoriaLogs is designed in the way that it performs a query only when the user reads query results. When user stops reading query results or pauses reading query results, then VictoriaLogs stops consuming any resources, CPU and memory and disk I/O. So don't worry, just execute this query on any amounts of logs in VictoriaLogs and see how it works. The next query, which selects all the logs with error word. Just type this word and that's it. That's a query which selects all the logs with this word. You can read more information about this type of query on the link below. What about limiting the number logs for the last 5 minutes? In this case, you just type this _ time filter, and specify that you want to see logs on the given time range. In this case, this query selects all the logs with error word for the last 5 minutes. What about selecting logs with error word or warning word? It's also very easy and natural. Just put this error and warning words in braces and put or keyword between these words, and that's all. What about selecting logs with error word and which do not contain some phrase? That's also not a problem and feels natural. Just put this phrase which you do not want to see in searched logs in quotes and put minus in front of this phrase, and that's it. What about selecting all the logs with error word? Usually the container name in Kubernetes is stored in separate log field, and this query shows how you can filter by log field. Just type the log field name, colon, and then type the word or phrase or any filter you want to apply to this particular field name, like in this case. This example is actually an optimized version of the previous example. When you compare both examples, you can see that the next example just puts this Kubernetes container name filter into curly braces and uses equal sign instead of colon sign for filtering. Such filter is named log stream filter, and it works usually much faster than the first type of filter because VictoriaLogs has optimized query path for stream log filters. You can read more about this on the link below. What about using some regex? For instance, selecting all the logs which contain some substrings which resemble IP addresses. It's also doable. Just put this tilde in front of regex, and that's how it works. Let's look at some analytics. The simplest analytics is the count of the number of logs for the last 1 hour. You just put the query and then put this count stats function after the pipe sign. That's how you can count the number of logs for the last hour. Let's look at a more complex example. For instance, let's extract top 10 IP addresses seen in logs over the last week. In this query, we specify the filter for the last 7 days. Then we specify the filter for searching logs which contain the remote adder equal quote phrase in these logs. And after that, we extract the remote adder IP address using this extract pipe. And after we extract this IP address into IP field. After that, we perform stats calculation by this IP group by this IP field. So we calculate the number of unique logs per each IP. And after that, we apply the sort pipe, which sorts this number of logs in descending order and returns only the top 10 such entries. So we will see in the end result, we will see top 10 IP addresses seen in logs over the last week. And this query can be simplified. We just replace the last 2 pipes, stats and sort, with the top pipe, which shows the same information as the previous query, but it is much simpler. You can apply the top pipe to any log field. For instance, this query selects all the top 5 logs with error word for the last 1 hour, grouped by Kubernetes container name log field. And let's look at not most complex, but non-trivial query, which selects the top 5 containers with the biggest error rate over the last hour. So what we do here, we just select all the logs for the last hour, then calculate stats by Kubernetes container name log field with the number of total logs and with a conditional filter which calculates the number of logs containing error word, and this number is named errors. Then we apply mass pipe. That's just mass calculations. We just divide errors by total and name this errors rate, and then we filter this errors rate, filter out all the things above 0 and below 1. And after that, we just sort the errors rate in descending order, and it works quite fast. Okay, that's almost all. I recommend you reading LogsQL docs and trying different features of this LogsQL query language and playing with it. Let's look at some production case numbers for VictoriaLogs. We run VictoriaLogs for the last 1 year and collect all the logs from internal Kubernetes staging cluster into it. During this last year, it has been collected almost 2 billion of logs, which these logs occupy 45 gigabytes of disk space. And if we compare the uncompressed size of these logs to compressed sizes logs, then the compression ratio is 55. So the uncompressed log size is 2.5 terabytes, and they are compressed into 45 gigabytes on disk. The RAM usage, memory usage for this VictoriaLogs instance is 250 megabytes on average. Of course, the memory usage may increase during heavy queries, but on average, the memory usage is 250 megabytes. And the CPU usage in steady state, it is 5% of a single core CPU. Of course, when you execute some heavy query, then the CPU usage may grow, maybe much bigger. What about resources for this VictoriaLogs container? It has 4 CPU cores, 14 gigabytes of memory, and a persistent volume with 100 gigabytes of size. And this standard HDD-based Google Cloud disk. So it has very low IOPS for reading and writing, and only 12 megabytes per second read-write throughput. So it's very small. And what about the performance of this VictoriaLogs? When you search for the last 100 logs with the error word, it takes 100 milliseconds. When you count the number of logs with error word for the last day, it takes half a second, and it finds 2 million of log entries. If you count the number of logs for the last 100 days, it takes 300 milliseconds, and it finds 500 million of logs. If you search for top 5 applications with the highest number of logs over the last 100 days, it takes half a second. If you count the number of logs with very rare words, such as foobar, for instance, across all the 2 billion of logs, it takes around 3 seconds and finds 350 entries. That's all. Here are useful links about VictoriaLogs and LogsQL, how to set up VictoriaLogs in the Kubernetes, how to ingest logs from other data sources, and about the last link is interactive command line tool for querying VictoriaLogs. Thank you, and you can ask questions.